Today is a review of polars. We did polars in pre-cal. If you were like first period, there's a lot of stuff that you do remember. A few things that were like, maybe, and then it came back to you and everything was great. So, the polar coordinate system is based on concentric circles. The two numbers in the parentheses are r and theta. R represents what? Do you remember? Radius of the circle, and theta is the angle that you go out to get to that point. Okay? So, let's review real quickly how to find the coordinates in both degrees and radians. We'll start with B. Here's B. So, give me a degree measure of this one. Give me an answer in degrees. What's the radius of that circle? 2. And how many degrees around do you go to get to B? 180. Okay, there's your first one. So we're going to make 4 ordered pairs where it's positive, negative, positive, positive, then positive, negative, and then negative, positive, and then negative, negative. So the positive, negative one is where you go out to the radius of 2, but you go around the other way. How many degrees would I go if I went the other way around the circle? Negative 180. Okay, now if the radius is negative, that means you go not in the direction of the angle, but the opposite way. So if I go negative 2, that would be going left, and then I'm right on the dot, which means I have to move how many degrees to get to the dot? 0. Okay? And then the fourth one would be negative 2, comma, what's another degree measure besides 0 that lands in the same place? 360. That'll work. I know those are both positive, but that's okay. All right, let's take these and convert them to radians. So the first one would be a radius of 2, and how many radians is 180 degrees? Pi. And the next one will be 2 and negative pi. Agreed? And then the third would be negative 2 and 0 radians, because 0 degrees is the same as 0 radians. And then negative 2, comma, 2 pi. Very good. All right. Let's jump to number 4. That's letter D down there. So how many circles out is D? 1.5. So our ordered pair is going to start with a 1.5. And how many degrees in the positive direction is it? It is on the 300 line, so it's 300 degrees. Okay? If I went in the negative direction, how many degrees would it be? Negative 60. So this is also 1.5 negative 60 degrees. So what if the radius is negative? So basically a negative radius would be going on the same line up to here and then flipping back. So what is the angle measure up here on the same line if I go up into quadrant 2? 120. Okay? It's always 180 away from the other angle that you found. So this one was 300. If I subtract 180, I'm at 120. That's how to figure out where it is. So if I go around these are almost kind of backwards because it's going around 120 degrees and then going a radius of negative 1.5, which means I go in the opposite direction, and that puts me at D. Okay? And then negative 1.5, and what is the negative angle that corresponds with positive 120? Not 140, negative 240. There we go. Okay, this is just good practice in the degrees and radians. So let's go convert them. So 1.5, comma, what is 300 in radians? It's right here. Is it a pi over 3, a pi over 4, or a pi over 6?
Pi over 4.
Not a pi over 4. It's a pi over 3. 5 pi over 3. It's 5 pi over 3. 6 pi over 3 is on 2 pi. So it's 1 back from there. Okay, and then 1.5 for the next one. Negative 60
Pi over 3.
is negative pi over 3. If you still have problems doing conversions between degrees and radians, as far as quadrant 1 is concerned, I know for a while I got real confused. Is pi over 6 30 or 60? I couldn't remember.
It's like opposite.
It is opposite, and another way to think of it is this. If you take this number, the degree number, and the denominator and multiply them, you always get 180. Okay? If you take the degree number and the denominator for quadrant 1 angles only and multiply them, you will get 180 every time. Okay? That's a good way to remember. So then negative 1.5 and 120. 120 is what measure?
2 pi over 3.
That is 2 pi over 3. And then negative 1.5 and negative 240. So that's negative over here. 4 pi over 3. That's the only one I haven't done yet. There we go. Okay. So, degrees and radians. Good there. Just points, individual points. Okay? So, what we're going to do now is talk about converting points from one to the other. Okay, converting from polar to rectangular. This box right here is everything you need to know. Okay, depending on whether you're going from polar to rectangular or rectangular to polar. Now you did learn these last year. As soon as we start working with them again, they're going to come back to you, I'm pretty sure, if they haven't already. So look at number 5. Let's do letter B. Now this is polar points, it says. Now sometimes you look at a point and you're like, well, of course it's polar. It's got a pi over 6 in it. But if it said 5, 0, it could be rectangular or polar. It's kind of hard to tell. So make sure you read to make sure you've got the right kind. So if I have r and theta, I'm going to x and y. What does it say x equals and y equals up here? It's right here. X equals r cosine theta and y equals r sine theta. So let's plug them in. R, 2 square roots of 3, cosine pi over 6. R cosine theta. So that's 2 square roots of 3 times, what's cosine of pi over 6? It is the square root of 3 over 2. Anything cancel? Does everything cancel? No, the 2's do. And what is the square root of 3 times the square root of 3? 3. So the x coordinate is 3. Okay, the y coordinate is r sine theta. So y equals r, which is 2 square root of 3, sine of pi over 6. So that is 2 square roots of 3 times 1/2. The 2's cancel again, and I'm left with the square root of 3. And so there is my answer. 3 comma square root of 3. Okay, you do letter C right now. Same process. You do letter C. Scooch. There. Answers on the screen when you're done. Any questions? All right. Moving on, let's look at going the other way, going from rectangular to polar. So this is x and y. How do we write r and theta? Now, there is something I need to make a note of, and you need to make sure you write this down. You need to note the quadrant. Okay? In the past problem, it didn't matter. You didn't have to look ahead of time to see what quadrant you were in. But with this one, you do. Because when you do tangent inverse for the theta, there are multiple answers. You have to pick the answer that matches the quadrant that you're in. Okay? So, let's do letter A first. This point x and y, what quadrant is it in? That's quadrant 4. So I'm going to write myself a little 4 right there to remind myself later. Okay? Now, the relationships for rectangular to polar are up here. R is equal to the square root of x squared plus y squared. So I write 3 squared plus negative 3 squared, which is the square root of 18. Agreed? I don't want a decimal. I want a simplified radical. What would 18 be if I simplified it? 3 square root of 2. 3 square root of 2. So this is going to be 3 square root of 2, comma something. So theta is tangent inverse of y over x. Negative 3 over 3. So that is tangent inverse of negative 1. Okay. In quadrant 4, what is the angle that has a tangent of negative 1?
Something over.
It's something over 4.
I.
7 pi over 4 will work. Or you could write negative what? Negative pi over 4. Either one is correct. So in this case, I'm going to go ahead and use the positive 7 pi over 4 because that's what you guys said first. And that is my theta. And there is my answer. 3 square roots of 2, 7 pi over 4. Okay, we're going to go ahead and do C together, just in the interest of time. What quadrant is C in? This is quadrant 2. So R equals the square root of negative 4 squared plus 4 square roots of 3 squared. Now that's a little tricky. So R equals the square root of 16 plus, do you know how to quickly square square roots of 3 without a calculator?
16 over 3.
It's 16 times 3. Square the 4, square the square root of 3. So 16 times 3 is 48. 16 plus 48 happens to be 64. So what is R? R is 8. Now R could be plus or minus 8. We're just going to go with the positive as we build our point. It's a little easier. Are you good so far?
Mm-hmm.
So now theta is tangent inverse of 4 square roots of 3 over negative 4. So that's tangent inverse of the square root of negative square root of 3. I stand corrected. Okay, we're in quadrant 2. We want the tangent to be negative square root of 3. It's not the pi over 4. Is it the pi over 6 or the pi over 3 over there? It's the pi over 3. Okay, the reason being, okay, tangent, do you remember what tangent, the graph looks like? It does this kind of thing, right? It increases. So as you go up into quadrant 1, the value should be getting bigger. Which is bigger, square root of 3 or square root of 3 over 3? Square root of 3. So the square root of 3 should be the highest one. It's bigger than 1 also. So it goes square root of 3 over 3, 1, and square root of 3. And I didn't hear that till this morning, and that actually makes a lot of sense to me. So that's going to help me remember, because I usually have to do my hand trick to figure out what the tangent of pi over 3 is. So what is the pi over 3 angle in quadrant 2? It is 2 pi over 3, yes. So there's my answer. Yes, ma'am.
Is it negative square root 3?
Yes. When you are ready, turn the page. Now, we have written points in rectangular to polar. We've changed from rectangular to polar. We've changed from polar to rectangular. Now we're going to change equations from polar to rectangular and rectangular to polar, okay? So, let's take and look at number 7. Convert the following rectangular equations to polar equations, and we're going to verify with the calculator. So we're going to graph in polar in just a minute. All right? So, y equals 6. We need to change that equation to have r's and thetas in it. So what does y equal in terms of r's and thetas? What does y equal? Y equals
Oh, theta.
r sine theta. So all we have to do is change the y to r sine theta equals 6. Okay? Now it's not done until you have solved for r. So how do I get the r by itself? Okay, in this case we're going to divide by sine. Inverse sine is when you try to get it off of an angle. So we're going to divide by sine, and so we get r equals 6 over sine of theta, which is a valid answer. And another form of the valid answer is to bring the sign up. What will it turn into when you do cosecant? Cosecant is the reciprocal of sine. So both of these are valid answers. Okay? So we're going to check ourselves by graphing it. So take your calculator, please. So Take your calculator, please. Push the mode key. Push the mode key and change it to polar. It's on the next to where you changed parametric. Now we change to polar, P-O-L. Push enter. And then push y equals. What do you see? R equals. Now, the other side of the equation has theta, so when you push the x key, it will now give you a theta. That's why it says x comma t comma theta. So, do we have a cosecant button on the calculator?
No.
No. So we have to type it in the first way, the first equation here. So, before we do, the equation we started with was y equals 6. What does that line look like?
This is a straight line.
Which way? Horizontal, vertical, diagonal, what? Horizontal, okay? So I want you to type in 6 divided by sine of x, and it will put a theta in there for you. You need to push zoom 6, or you won't see it. Zoom 6. Is that the line y equals 6? Yeah. Okay, but I want to show you something else that you may not have noticed when you graph this thing, okay? I want you to go back to y equals, and I want you to type over the 6 with a 6 again, because that resets the graph. It allows it to graph it again. I want you to notice which direction it graphs. Push the graph key now. Just graph. Which way did it graph?
Right to left.
Right to left. Why? Why?
Oh, because
Is it like
because the unit circle goes from left to right.
It's going in the direction that the unit circle goes. When you do the unit circle, which way do you go? You go left. And so the graph says, okay, 0 degrees, I graph a 6. 10 degrees, I graph a 6. 20 degrees, I graph a 6. 30 degrees, I graph a 6. And so it's going from left to right, all the way around the circle. So, that's why. Now, do me a favor, push the window key. Instead of T-min, T-max, and T-step, we now have theta-min, theta-max, and theta-step. And it's still from 0 to 2 pi, which is good, and it gave us the whole line that we needed, okay? Usually, when we do parametrics, we tend to play with the t's. In polars, we don't really play with the thetas very much. We usually leave them alone. The only thing we play with is how big the screen is, okay? Any questions so far? All right, let's do letter B. Let's put the calculator aside. 4x minus 2y minus 1 equals 0. Okay, I want r's and thetas. So, based on what the chart said on the front, what does x equal in terms of r's and thetas?
R cosine theta.
R cosine theta. Okay, that takes care of x. Minus 2. What about y? R sine theta minus 1 equals 0. Okay, I need to solve for r. Okay, how many r's do you see?
2.
2. So, do you remember back in when we did implicit differentiation and we had multiple dy dx's that we had to solve for? Do you remember what we did? We factored it out, but first we did something else.
Moved everything to one side.
Moved everything that didn't have that thing, the dy dx, to the other side. We're going to do exactly the same thing here. Okay, so what needs to move to the other side?
4, 2, 1.
Not, well, we can't move the 4 and the 2.
1.
Just the negative 1. It's the only thing that's going to go. So we write 4r cosine theta minus 2r sine theta equals 1. Now what?
Divide.
Factor out the r first. Now I know I could factor out 2r, but I only want to I want r by itself. So if I take out r, that's 4 cosine theta minus 2 sine theta equals 1. Agreed? So in order to isolate r, I've got to divide both sides by the parentheses, so r equals 1 over 4 cosine theta minus 2 sine theta. And that is my answer. Now, before I go to the calculator, if I took letter B's original equation and I got y by itself, what kind of graph would it be? It would be linear, because x and y are both to the first power. Is it going to be either horizontal or vertical, or will it be diagonal? It's going to be diagonal, okay? So let's check and see if we get a diagonal line with that. So y equals, I'm going to do the fraction bar. If you don't do fraction bar, you got to put parentheses around the bottom. 1 over 4 cosine theta, close that parentheses, minus 2 sine theta. Otherwise you will get the wrong answer. Now it's going to graph the line kind of weird. When you push graph, look what it does.
Is it gonna keep going?
No, it's done.
Okay. I think you did like this.
Okay, now push zoom 4 to kind of get a little closer. Zoom 4. What did it kind of do? It just went.
It started
Wait.
from-
I'm going to move it over so that the people who are watching the video can see what happens.
Oh, it's like-
Kind of goes. Whew.
oh, it's-
And it has to do with the order in which it does the thetas of the angles. Okay? So those two lines are on top of each other. It is the same line. It just doesn't start at one end and go to the other. It kind of does a little bit up and then down and then back up again. It's just really strange. But it is a diagonal line. Jump down to number 8. Convert the following polar equations to rectangular equations. Now we're going to go backwards. This is a little trickier. Okay? Now, in order to make x's and y's, we have to have our cosine theta and our sine thetas somewhere in our problem. Okay? Now, I see sines and cosines right there, but I don't see r's attached to them. So, kind of keeping that in mind, if I was to, like, say, solve for theta, let's say I was trying to solve for theta, which I'm not, what would be the first step I would do?
Multiply by the denominator.
Multiply both sides by the denominator. Get rid of the fraction. We hate fractions. We don't want them anymore. But no, we really don't hate fractions. So let's do that. If you multiply both sides by the denominator, what happens to the left? You get r times sine theta plus 3 cosine theta equals just a 2.
Can't you distribute?
Yeah, and we're going to distribute. Oh, and now we get the r's we need. R sine theta plus 3r cosine theta equals 2. Now, why did I stick the r in the middle? Because r cosine theta as a unit is x. So what does r sine theta equal again? Y plus 3x equals 2. Did I get rid of all my r's and thetas? I'm done. I don't have to solve for y. You could. It'd be real easy, wouldn't it?
I would choose to subtract the 2. Can you do that?
Yeah, you could. You could. Usually when you're writing an equation with x and y, you get y by itself. So that's what we need to do here. All right, now the next one looks very similar. However, it's going to turn out very different. So we're going to start the next one the same way. Multiply both sides by the denominator. So that'll be r times 1 plus 2 cosine of theta equals 2. So what is this going to say if I distribute? R plus 2r cosine theta equals 2. Okay? So what is the second term? It's going to be just x, right? 2x. But that first term, r, do we have some sort of an equation that relates r's to x's and y's? Okay, go ahead and say it louder for me. It's
R equals the square root of x squared plus y squared.
r equals the square root of x squared plus y squared. So we can replace that r with this, change this to 2x equals 2. Did we get rid of all our r's and thetas? We are done. Officially done. Now, you could solve for, you could get rid of the square root by moving the 2x to the other side and squaring both sides. But I'm not going to go down there. That's more work than we need to do.
So with the square root of x squared plus y squared be x plus y or no?
No. Think about this. The square root of 3 squared plus 4 squared, if you square 3 and 4, is 25. Square root of 25.
Oh yeah.
So does the square root of 3 squared plus 4 squared does not equal 3 plus 4. Can't do it. Okay? Are we good on this? Yes.
So what if you get rid of all of your sines and cosines and you only have x and y's, but it's not the same thing. It's not the same equation as that. could you still get it correct?
Yes, yes. It is still, they will however you do it, the two equations can eventually be made to be the same. Okay? All right. So, we have done polar points to rectangular and back again. We have done polar equations to rectangular and back again. Now we're going to do something we need for the next step. We're going to change polar to parametric. And you may think, oh, that sounds awful. It's the easiest one of all. It is so easy. Okay? Here we go. Polar to parametric, we use that x equals r cosine theta, y equals r sine theta. Do you remember yesterday that when we did parametric, sometimes we had x equals something with thetas and y equals something with thetas? Do you remember that? Okay? Parametric just means 3 variables. So in this instance, instead of getting rid of both r and theta, we're getting rid of just r. Just r. Okay? So what we do is we write down x equals r cosine theta. But what does this problem say that r is? 4. So 4 cosine theta. Y equals 4 sine theta. I'm done. What? I told you it was easy. Okay. Did I create an equation for x and y that both have a theta in them? Did I get rid of the r's? Yes, I did. I'm done. That's all we do. You take what r equals and substitute it in to these two equations right here. That's all you do. Okay? So what would b be? X equals, be careful. Instead of writing r cosine theta, I'm going to write 4 sine theta cosine theta. Okay? And y usually equals r sine theta, but r is this, so we write 4 sine theta sine theta, which we can rewrite as 4 times what? Sine squared theta, exactly. So here's my x equation, there's my y equation. Okay, you do the last one. There you go. Any questions? Okay, turn the page. All right, now let's take a look at the calculus of polars. We're going to start getting into the calculus. First of all, we're going to talk about the slope. The slope, dy dx, just box in the first 2 things in that line. It's just dy d theta over dx d theta, which is the same thing we've always done. The other part of it is kind of a way to help you remember it. I just say take the derivative. It's just much easier to do. Okay? Now, you've also got to remember that dy dx cannot be 0, which makes sense because if it's 0, you're going to have 0 on the bottom of a fraction, which is bad. So, down here, to find horizontal tangents, you set dy dx equal to 0 provided that dy d theta equal to 0 provided that dx d theta is not 0. And to find vertical tangents, we set dx d theta equals 0 provided that dy d theta is not 0. Okay, so what does that mean in simple English? To find horizontals, we set the dy d theta to 0. To find verticals, we set the dx d theta equal to 0. If they have any answers in common, you throw them out, because that means dy d theta and dx d theta are both 0, which means it's a slope of 0 over 0. And we don't know whether it is a cusp, whether it is a vertical tangent, what's going on at that point in the graph. So we just throw it away. All right? Now, we're going to do 10b only, but I'm going to tell you right now, he did not leave enough space under 10b to do all of 10b, so you're going to need probably the entire section at the bottom to do 10b. So we're going to do b. This is a lot of trig, okay? So I am going to do the x equals and the y equals on either side. We're looking for the theta values where it has horizontal and vertical tangents is all we're doing, okay? The first thing we do is what we did at the bottom of the previous page. we're going to make parametric equations out of these polar equations. Okay? So I'm going to basically mark out A so I don't get myself confused. Over here, x equals r cosine theta. So in place of the r, I'm going to put this right here, the 2 parentheses 1 minus sine theta. So 2 parentheses 1 minus sine theta times cosine theta. Remembering that all of this is r. Now we are going to have to take the derivative of this thing. And I have 2 trig functions in there, which means I'm going to have to do product rule. So to make things a little bit easier to do that, I'm not going to distribute. What I'm going to do is move the cosine kind of in between the 2 and the parentheses. So x equals 2 cosine theta parentheses 1 minus sine theta. And I'm going to do product rule to that. 1d2 plus 2d1. Okay. So dx d theta equals 1 is 2 cosine theta. What is d2? What's the derivative of the parentheses? Negative cosine theta. Agreed? 1d2 plus 2, 1 minus sine theta, times, this will be negative 2 sine theta. Okay, we need to multiply everything out and see what we have. So this equals negative 2 cosine squared theta. And now I need to distribute this negative 2 sine theta back into the parentheses. So I'm going to have negative 2 sine theta plus 2 sine squared theta. And we're supposed to set this equal to 0. Okay, what do you think that I can do? What can I do? If I got to solve, I've got to set it equal to 0.
Take out 2.
Take out a 2. Or how about let's just divide it out. If you divide it out, then it's gone. Divide both sides by 2. Okay? So then we'll have, it's a great idea. Negative, oops, I wrote the 2 again. Why did I do that? I'm getting rid of the 2, so let's write it down again. Negative cosine squared theta minus sine theta plus sine squared theta equals 0. Okay? Good idea. Very good idea. Okay. It's been a while since you've done this. What should I do to what's left?
Doesn't sine squared and cosine squared like equal 1?
Equal 1.
That's a good thing. Let's talk about that. What do you have to do to sine squared and cosine squared to make it equal 1? You add them or subtract them?
Subtract them. So wouldn't it be sine squared theta minus, the front one is negative cosine.
Okay. The formula says sine squared plus cosine squared equals 1. But what we have up there is sine squared minus cosine squared.
We can factor out a negative 1.
If you factor out a negative 1, the cosine squared will turn positive, but what will happen to the sine squared?
Negative 1.
It'll turn negative. So that's not going to help.
Sine squared minus 1.
Say that again.
Turn the cosine squared to sine squared minus 1.
You are very, very close. I am going to make this all into the same trig function. And you are right, but you have it reversed. Okay? Now, do I want to turn them all into sines or turn them all into cosines? There's fewer things to change if I change the cosine to a sine. Okay? Because sine squared plus cosine squared equals 1, I can change any cosine squared to a sine squared or any sine squared to a cosine squared. But I cannot change this to a cosine. I can't. So since this one is stuck as a sine, I have to change it all to sines. Okay? So, the formula says sine squared plus cosine squared equals 1. So, cosine squared equals 1 minus sine squared. And that's what I'm going to use right here. So I'm going to move over a little bit. Negative 1 minus sine squared theta minus sine theta plus sine squared theta equals 0. So now I have all sines. So now let's just do some algebra and clean it all up. So So we have, to save a line, I'm going to distribute the negative this way. It's -1 plus sine squared. Okay, so how many sine squareds do I really have? I have 2 of them, don't I? So I have 2 sine squared theta minus a sine of theta minus a 1 equals 0. There we go. That looks much better. Okay. What now?
2 sine squared theta minus 1.
Add 1.
Add 1 sounds like a logical thing to do, but it's not going to help.
Could you take out,
just like take out a sign.
That's a good thing. Can we take out a sign?
No.
Not really, because the 1 doesn't have 1. So moving the 1 doesn't help. I'm telling you right now, it doesn't help. Taking out a sign is not a possibility. There is a third possibility, and that's what we need to do.
changing
Take out a
it
one.
into
Sine theta minus give up the
Okay, it's the dreaded F word of mathematics. Factor it. We are going to factor this thing. And you're like, ew, how do you factor that? Okay, I'm going to show you a neat trick to help you make it easier to factor. I want you to change all of those signs. We're going to do a U substitution in this problem. Not a calculus U substitution, a pre-cal U substitution. Watch this. Every time you see a sign, write a U instead. So this would be 2u squared minus u minus 1 equals 0. Does that look a lot more factorable? Yeah, that looks a lot better. So what we're going to do is we're going to finish the problem in u's, and then we'll change the u's back to signs. Okay, so factor, 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 factor. First term is 2u squared. So what has to go in the front of the 2 parentheses? 2u and 1u. 2 times 1 is 2u squared. Okay? The back of the parentheses has to be, multiplies me -1. So that tells me my only choices are 1 and 1. Now the trick is, how do the signs go? Plus and minus. It's going to be one of each. Destiny, do you have a question?
Yeah, for the U's, how are they able to be the same U's if they're different signs?
Okay, sine of theta is what u is. So since it says 2 sine squared, I just say 2u squared. You see what I'm doing? Okay. So what I'm going to do is I'm going to put negatives in both of them, and one of them I got to change to positive. So which one do you think is going to be the negative, the first or the second? I heard first and a second. Let's try the first being negative. That means the outside would be +2 if the second one was a positive, and the inside would be -1. Is that what I want? +2 minus 1? No, that's backwards. So this one needs to be the positive, because now the outside is -2 and the inside is +1. What's -2 plus 1? -1. And that's what I want, -1u. Okay? Oh my gosh, algebra 2. All right, so set each one equal to 0. So 2u plus 1 equals 0. What does u equal? -1/2. And u minus 1 equals 0, so u equals 1. Agreed? Okay? But we're looking for angles. That's not u's. We're not quite done with that. So we're going to have to kind of steal some space. We're going to move up to about right there. Change your u's back to signs. Sine theta equals -1/2. Sine theta equals 1. Theta equals. Now for me, I have to draw a little unit circle to remind myself where this happens. Sine is negative in quadrants, the 2 bottom ones, 3 and 4. Sine to be -1/2 is going to be the closest to the x-axis. What is that angle right there? 7 pi over 6 is what it is. Okay? What about that one right before I get to 2 pi? That's the 11 pi over 6. And then finally here, where does sine equal 1? Pi halves? Is that the only place? Yes. So there are my 3 answers for horizontal tangents. No, excuse me. Which kind of tangents are these? This is vertical because it's dx d theta. These are the vertical tangents. Okay, I picked the long one first. Horizontal tangents is much easier because I already know what the answer is going to be. Okay, are you with me so far? All right, let's move this back down. And so we're going to do the y. Draw a line kind of like this. Whee. Let's do the y right here. Y equals, now remember that y equals r sine theta. So we copy r to 1 minus sine theta, sine theta. Now last time I told you not to distribute. And the reason is because they were 2 different trig functions. But now that these 2 are the same, it's much easier to go ahead and distribute, okay? So we're going to distribute the 2 and the sine at the same time. So what's the first term going to be? 2 sine theta minus
2 sine squared.
2 sine squared of theta. Very good. Okay, now it's time to do the dy d theta to this one. Now I moved over a little bit, but I really don't even think I need to have moved over that far. Okay. What is the derivative of 2 sine theta? 2 cosine theta. That takes care of the first term. Minus. Now be careful with this. This right here is, remember, 2 sine theta squared. Actually, negative 2. And that is chain rule. So the 2 comes down, makes a negative 4, parentheses to the first, and in the parentheses goes the sine again, times the derivative of the inner, which is cosine. Okay? So, I'm done. That was not bad, was it? That's it for the derivative. So 2 cosine theta, no, that's not it for the whole problem, sorry. 4 sine theta cosine theta equals 0. You can only change sines to cosines or vice versa if they are squared, which means these guys are all stuck the way they are. But I can take out a cosine. Always look to factor. Usually factoring is the key to solving. I can take out more than a cosine. I can take out a 2 cosine. 2 cosine theta parentheses. What's left? 1 minus 2 sine theta equals 0. Okay, we're not going to change this to u's. We really don't need to because we're done factoring. That's it. So we set each one equal to 0, the outside and the inside. And we work each one individually. On the left, what should I do first?
Divide by 2.
Divide by 2. So I get cosine of theta equals 0. Where does that happen? Pi over 2 and 3 pi over 2. Okay? That's that answer. Oh, I shouldn't have made them like that. I should have gone down, but that's okay. How do I move this over? So it's 1 equals 2 sine theta. Sine theta equals 1/2. Quadrant 1, what's the answer?
Pi 6.
Pi over 6. 5 pi over 6. And these are the horizontal tangents. Okay. Your final step is to ax, as in chop out, any answers they have in common. Do they have any answers in common? Pi halves. They both have pi over 2. So we mark them out on both problems. They cannot be answers. because it's a point where both the dy d theta and dx d theta both equal 0. A lot of trig, but once you get past the trig, it's just solving for theta. Yes, sir?
How do you know that so if you do this and then you get what theta equals for the x's, is it always going to be the vertical tangent? And then y will always be...
Yes. Dx d theta always gives you vertical tangents. If you set it equal to 0, dy d theta always gives you horizontal tangents. Okay? Any other questions? All right. The last thing we're going to do is, notice they don't give you much room. You don't need much room. Okay? Now this is a little bit unusual. What I want you to do before we talk about those directions is take your calculator, please, and I want you to put 11a into y equals 4 cosine 3 theta. Just like that. Move it up so you can see a little bit better. Push, zoom 4. We get the nice little, pretty little, loop-de-loop-de-loop.
Oh yeah. Wait, what's it?
We called them roses, even though they look like daisies. Now, take a look at this graph for me, please. This is a polar graph. Where do you think the pole is?
The one that touches the...
It is the origin. The pole is the origin, okay? How many times does this graph cross the pole?
6.
1, 2, 3, 4, 5.
It is a total of 6 times. It goes through the pole 6 times, okay? So sometimes we want to know where those points are, as in where the graph is tangent to the pole, okay? So put the graph aside for just a minute. Let's read what's in the little bitty box right up here. It says, now this is, my first period is like, this is reading math. I'm not good at reading math. We'll kind of decipher this as we go. If r, which is the same thing as a function of theta, is equal to 0. So if this thing equals 0, at a specific angle we call alpha, and what is this saying right here?
The derivative of the angle?
The derivative of alpha is what?
Not equal to 0.
Not equal to 0, okay? Then we say the line theta equals alpha is tangent to the pole, okay? So we're looking for where r equals 0. So we're going to set this equal to 0 and make sure the derivative at our answers does not equal 0. Okay? That's what this is saying right here. So we're talking about tangent to the pole, and this is what has to happen. So we just set r equal to 0. We're not taking any derivatives yet. We're just going to set this thing equal to 0. Just like that. Just set it equal to 0. How do you solve for theta? Divide by 4 first. So both sides divided by 4, we're going to get cosine of 3 theta equals 0 still. Agreed?
Yes.
Okay. Now, what we're going to do is we're going to pretend for just a minute that 3 theta is just a theta. Okay? So instead of writing theta equals blah, 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 we're going to write 3 theta equals blah, 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 blah. Now, where is cosine equal to 0? Pi halves and 3 pi over 2. Okay? Now, the importance of this 3 is this is how many times you must go around the circle to get your answers. 3 times around the circle. Whatever your coefficient on theta is, that's how many times you go around the circle to give me answers. Otherwise, you won't get them all. So, pi halves is straight up. 3 pi over 2 is at the bottom. If I come back around and straight up again, where am I? Say it again. 5 pi over 2. So the next one is 5 pi over 2. If I go to the, look at the pattern, what's the next one going to be? 7 pi over 2. That's twice around the circle. Now we got to go one more time. What's the next one? 9 pi over 2 and 11 pi over 2. So we go around the circle however many times the number in front of theta is. Now, to solve for theta, how do we get the 3 off the theta? Divide by 3 or multiply by 1/3. And the reason I want to say that is because multiplying by 1/3 is what just saying multiply the denominators by 3. Right? So theta will be pi over 6. 3 pi over 6, which reduces to what? I multiply this by 3 on the bottom, that's 3 pi over 6. That reduces to pi over 2. 5 pi over 6. 7 pi over 6. 9 pi over 6 reduces. 3 pi over 2. And then 11 pi over 6. Now, how many tangent lines to the pole did we say we had? 6. How many answers did we get? 6. They're probably all valid. Now, what we're supposed to do is double check ourselves by taking the derivative of this thing. So what is r prime going to be? What's the derivative of 4 cosine 3 theta? It is 12 negative sine of 3 theta. Okay. Now mentally, we're going to do this just real quick. If you plug in pi over 6, 3 pi over 6 right here, are you going to get 0? No, sine equals 0 at 0 and pi, right? If I plug in pi over 2, that'll be 3 pi over 2, nope. 5 pi over 2, nope. 7 pi over 2, nope. 9 pi over 2, nope. So all of these are good answers. So we're good. Okay? So we just basically mentally check them all to see, make sure that none of them made the derivative equal to 0. I want you to do letter B real quick. It's a very short one. Only has 2 answers. Only has 2 answers. See if you can do it. When you're done, you can check up here and see if you got what I got.
So how do you get so you get pi halves, and then how do you calculate what it would be if you go around?
One more time, add 2 pi to it. 2 pi is once around the circle, so add 2 pi to pi halves. That's like 2.5 pi, which is 5 pi over 2. So I distributed the 3. You didn't have to. You could have just divided both sides by 3 right away. But you still end up with sine of 2 theta equals 1, which is at pi halves, and then once around again it's 5 pi over 2, and then divide by 2, and you get pi over 4 and 5 pi over 4. Okay? Any other questions? All right, we are done for today.